Hello and welcome to our first session of Hadoop. We'll discuss about Hadoop and the big data, and let's discuss in detail. And we'll first talk about the unit of data that we have. So, unit of data. So as we all know, 1 bit is the smallest unit of data that we have. Now, 1 byte is equal to 8 bits, right? And 1 kilobyte is equal to 1024 bytes. Let's keep it very simple and let's make it 1000. That's it. Then 1 MB is equal to again 1000 kilobyte, which is equivalent to 10 to the power 6 bytes. And we have then 1 GB, which equivalents to 1000 of MB, which again equivalents to 10 to the power 9 bytes. 1 TB is equal to 1000 of GB, which equivalents to 10 to the power 12 bytes. 1 petabyte, I mean till now we know it's a gigabyte, it's terabyte, and then petabyte equivalents to 1000 of terabyte, which is equivalents to 10 to the power 15 bytes. Then 1 exabyte is equal to 1000 of petabyte, which is again equivalent to 10 to the power 18 bytes. 1 zettabyte we have, which is equivalent to 1000 exabyte, which is again 10 to the power 21 bytes. Then the next unit is 1 yottabyte. 1 yottabyte is equal to 1000 zettabyte, which is equivalent to 10 to the power 24 bytes. And the last and the biggest unit is 1 XB, which equivalents to 1000 yottabyte, which is 10 to the power 27 bytes. Now you can just imagine how data units started with a bit in the late 60s, 70s, and we were talking about byte and kilobyte, and then we moved to MB and then gigabyte, and now we maximum heard about terabyte. We never talked to petabyte or exabyte or zettabyte or yottabyte or XB. But believe me, the zettabyte and yottabyte and exabytes are very common in the world of big data. And then now you also can imagine that for the smallest storage device, yes, small. Why? Because if you see that we have XB of unit of data, then in front of that terabyte is really very small. So when we go for buying a new laptop, a computer, or any storage device, we ask for maximum 2 terabyte or 5 terabyte, which we consider as max. Now you can just imagine how much the data would be when we deal with yottabyte or exbyte. Even terabyte is also a big amount of data. So we can say up to this much, all are small, and after this, all are big data. Now the question is, what are the sources of big data, right? Sources of big data. Why big data? Sources of big data we'll discuss, but why big data? We can say with the time we are growing and we are having more and more data if we consider the history and the present, right? Now let's talk about the sources of big data. So what are the sources of big data? So big data, I can say camera flicks that you have. Camera used to take a lot of big data. Now these days, if you buy a new phone also, usually within a couple of seconds you will see data reaches to GB, and which is very small amount of data for them. Camera flicks, then CCTV footage that we generally capture, and now these days everywhere CCTV camera is there, which actually store a lot of humongous amount of data. Then the sensors, these days, like if you're making technology advanced, there are a lot of sensors that we use and that actually stores a lot of data. Then how we can forget about our social media sites, social media like Facebook. So now you can imagine, like for your profile, if you do any like, comment or any history, Facebook basically stores all this data. So like for a single profile, how much data is it? And there are millions of users on Facebook and Twitter, so there are billions of data the social media site usually process every day. So these are some small examples that we can say. That's a very small examples, but very noticeable example of big data. And also Google is also one of them, which process the big data. Now there's one question, like Google provides lot of data or services, I can say lot of services like Gmail, Map, right? Google search engine. So, and all are, when you say like how much you are paying for that, these services, you will say zero. You are not paying anything for these services. Yeah, but true, you are paying for internet. But for using this, I mean, you are paying zero. So from where Google is earning actually? So suppose when you log in as dave@mail.com, so I mean gmail.com, log in as a user as a dave@gmail.com, and then suppose your account is already logged in and you go for Google and search it as like buy new iPhone 6s something, or in a day you can imagine how much search you usually do in Google. All these data Google actually stores and sell it to companies like Amazon, Flipkart. That's why when you will search for buy new iPhone 6s, and you will get an ad from Amazon and Flipkart about offers like, okay, 10% off or some off and something, right? So this is the way how Google or Facebook also, Facebook is one of them also, like which actually keep the record of your activities and process it and sell it, I can say. So for processing this data, for storing this data, they actually deal with humongous amount of data. Okay, so these are the major sources of the big data. Now let's discuss like why we need big data. I mean, why can't we go with normal SQL that we had in that we already have actually? Why we cannot process it? So we can say, why big data? Why not? So let's discuss in detail. Suppose In Bangalore, let's consider SBI ATMs of 10 places. Okay, in Bangalore, let's consider SBI ATMs of 10 places where the query is to process to find out max transaction that happened in among these ATMs in 10 years. So you're getting my point, right? So we are looking for the max transaction among these ATMs in 10 years. So if I'm a normal SQL guy, let's say I'm a normal SQL guy, what I will do, I'll just try to fire a query saying like select max of transaction column that we have, suppose from the table name, any table, like say bank detail, and what we'll do group something, by some way we'll group, and then we can expect the output as okay, maximum amount is this, some amount we'll get, some amount we will get. But tell me one thing, is it that simple to get the result quickly? Because I'm talking about 10 years of data of 10 places ATM. Let's say in 1 year, these 10 places gives about 10 TB of data. Then in 10 years, it will produce, let's say, 100 TB of data. So do you think so? If you are aware of Oracle SQL query, do you think so? The single line query will actually can deal with 100 TB of data? And if it can deal also, so how much time it will usually take? Let's consider that for processing 1 GB of data, it usually take, let's say my system is very high configured and we have a high configured RAM and everything. So how much it will take actually? So let's say for processing 1 GB of data, it takes 10 minutes of time, then your data will process. Then I'll say okay, 1 TB, how much time it will take? For 1 TB it will take 10 into 1000 minutes, which equivalents to 10,000 minutes. Now I'm talking about 100 TB. 100 TB. How much it will give us? You can imagine that's almost 1 crore, I can say, of minutes. And if you can actually go and convert it into, then you can get to know how much it is. So we have this much of minutes, we'll convert it into hour. Lakhs, 10 lakhs. Good. So let's convert it into hour. So we have this much of hours. Okay. Then convert it into days. We have this much of days, and then convert it into year. So I can say 365, which is nothing but 19 years it will take minimum. So can anyone wait for 19 years to get the maximum transaction for processing this data? Right. Let's take another example in order to understand the things in more clarity. Suppose if I have employee details of a 100-year-old company, and we have employee details, let's keep it short, like EMP ID, then I can say EMP name, then I can say EMP place. Just keep it simple, EMP place. Okay. So I have this in a file, suppose this detail in a file called as employees.csv, which is nothing but comma separated values. which is again comma separated values, which is again your Excel file. Okay. So this is the column that we have. So suppose I have a data called 101, then name called Dev, somewhere places called Bangalore, and suppose we have like this data, and overall it's about 300 TB of data. It's about overall 300 TB of data. Now what I can say is, let's process the 300 TB of data by using Java. So how we'll proceed? We'll write the main method, right? We'll write the main method. So public static void main of string. Then I'll use scanner because it's very simple to use. Scanner is a class which accepts the input from either from file or from the console. So new scanner, I'll read the file. So I'll put some path name like edrive of employees dot csv. Please avoid any typos. Then what would happen? It will scan this. So how it will scan now? So how to process this? Will I use while loop and will say sc dot has next, which will process each line one by one, like 1001 this, and then suppose this again 2, let's keep any name like David, it's fine, and then okay. So we have this. Now I want the line actually. So what I'll do, I'll create a string line which is equivalent to sc dot next, if you are aware of these things. So we'll get the line because it processed line by line, so we'll get the first line in first go, and then I am interested. So what my question is to get the details of all employees who are from Bangalore. So get the detail of all employees who are from Bangalore. So well, I'm more interested in the EMP place. So what I'll do, I'll first create an array of details. Then I'll say line dot split. I'll split on the basis of, it's a comma separated. So I'll base, when I say comma separated, it means each fields are separated with a comma. It's not visible, but it's, yeah, each field is separated with a comma like this. In Excel you cannot see comma, right? It's always in a tabular format. So yeah, so this is our details. Now I want place. Okay, place. So how about the place? Place will be details of 2. Why 2? Because at the 0 position we are having employee ID, at the first position we are having name, then in the third position, which is the index number 2, which would contain actually the place. So we'll get the place. Now we'll put our condition if place dot equals ignore cases of Bangalore. Then I'll write some custom method. Which will actually store save to what I can say CSV. Means I'm trying to save all the Bangalore employees detail in a separate CSV format. So for that purpose I have just created one method and I'm giving that line which is actually the detail of the employee, and I'm done. So this would be my logic if I actually want to process all the employees who are working from Bangalore location. Okay, so let's say there are 300 TB of data. So for processing 4 GB of data, it took 12 minutes, I can say. Okay, so for 1 GB, let's say it will take 3 minutes. Okay, and we are talking about 300 TB. So let's convert it into 1 TB, which will again takes 3 into 1000, which in turn 3000 minutes. Now again we are talking about 300 TB, which equivalents to 3000 into 300, which again 9 lakhs minutes. Okay. Now if we'll go and convert into number of years or days or month, whatever you are saying, first convert into hours, which is equivalent to this, and then days, which is this, and then years, which is 1.7 years. Nobody will wait for 1.7 years to process and to get this result, right? So we need something. We need a framework. We need a system that will actually process this humongous amount of data and will give the result in a considerable amount of time. When I say considerable, it doesn't mean like so quick, within a second. No, considerable means okay, it can take an hours, couple of hours, or a day at least. But when I say 1.7 years, it's really long to wait for that. Or in the previous example, when I say 19 years, it's really long. We cannot wait and cannot be allowed also, right? So in order to process such amount of data, introduction of Hadoop came into the picture. So what is Hadoop? Hadoop is a Java framework. Hadoop is a Java framework, and what it actually do? Which process the data in batch. I'll talk later, like what is a batch processing data and all. I'll talk this, what is real-time processing data, what is online transaction, OLAP, OLTP. We'll talk about this in our upcoming classes. So Hadoop is a Java framework which processes the data in batch. And one more thing, Hadoop can run on commodity hardware. What is this commodity hardware means? Commodity hardware means a daily use system. Right? Means not very high configured, not very high configured system, I can say. Like if you take a system take a system which is 10 years old, okay. Now add a RAM of let's say 2 TB in it, not 2 TB, sorry, I'm so sorry, 2 GB, and add a 2 TB of hard disk. Then this is your commodity hardware, and you can run your Hadoop and you can make it as a part of your Hadoop cluster. Okay, so I'll talk about what is cluster. So cluster and nodes we will talk in detail. So I'm just giving you an overview that Hadoop can be executed on this commodity hardware system. Okay. Now there's a two terminology where is very important, which is one is scaling. Okay. What is scaling? Scaling means advancing, or I can say in general term, upgrading the thing. So we can do scaling in two ways. The first way is horizontal. The second way how we can process is vertical. What is horizontal scaling and vertical scaling? So, sorry. What is horizontal and vertical? Okay, so suppose I have one system. This is my one system. This is your system. Okay, so let's talk about vertical scaling. And you are actually upgrading it. When I say upgrading, means there must be a limitation, right? Means how much there always a limit at how much upgradation you can do in your system, like in some system, suppose you cannot go more than 50 GB, I can say 24 GB of RAM. That's the limitation. And as well, you cannot go beyond 5 TB of hard disk. So vertical scaling is nothing but the upgradation in same system. You're doing upgradation in same system. You keep upgrading the system to process lot of data. I mean, you are dealing with Hadoop, right? So and I already talked about the unit of data. So how much data we are having and how much data in the future we can process. So you can do in two ways, either through vertical or horizontal. But if you go with vertical scaling way, you have to, there is a limitation, and you will have to limit yourself for that. Okay. So maximum you can do this with the vertical, whereas if you go with hard disk, I mean horizontal scaling, it means connecting multiple systems together, including your commodity hardware as well, Connecting multiple systems together, including your commodity hardware, means if you have system 10 years old and if you want to upgrade, like okay, I want to upgrade with 2 TB, and that's what I have discussed, like suppose 2 GB and 2 TB of hard disk, and you want to utilize it as in clusters, you can 1, 2, 3, okay, and you just keep one master node, that's it, and you just connect each system with this master node, and then you are done. Now suppose this is your commodity hardware, very high end, that doesn't matter. Let's say I have this 16 GB with having some 2 TB. Now again I have 16 GB with again 2 TB, let's say very small, again 16 GB, then let's say 5 TB. Again we have 16 GB or 8 GB, that is small also, and 1 TB suppose, and this is a master which is operating. Now tell me, your one system max you can go 24 GB and 5 TB, and now you tell me what's the total capacity, and that's not limited, you can add more and more and more. As of now I'm saying what's the capacity of this system, and which is considered as one, not as multiple. So what will tell it as, will say, yeah, it is 56 GB with having 10 TB of hard disk. So now tell me, which is ideal, vertical or horizontal? And it looks very clear that yeah, horizontal is ideal for our Hadoop. Now you can see this entire thing is called cluster, where we have multiple systems, and each system is called as nodes. Each commodity hardware that you will use, that is called as node, and collection of these nodes with a master is called as cluster. So what are the prerequisites if you want to install? Suppose for learning purpose, generally we'll go for single node system, single node system, which is nothing but your your system, means installation in your laptop. Okay, that's it. So ideally, what are the things that you require? You need a VM image along with the Hadoop installation that is required, and Hadoop is an ecosystem, so it contains, so you need to ecosystem, so you need to install all the ecosystem individually. So RAM size, I can say like, okay, 8 GB is fine. Give some 50 GB of space as well. So so this would be fine. Now what is how you can go with Hadoop and what is Hadoop? So let's talk about that. So Hadoop is an ecosystem which contains, so what are the part of ecosystem? There are a lot of parts, but I will discuss few: pig, hive, scoop, flume, Uji. Okay, then we have zookeeper, etc. I can put it here, okay, because there are a lot. Now, so if you want to install Hadoop, you need to have your VM player. First, the thing is VM player, not the VM image. VM player. Then you need to, if you want to install Hadoop, then you need to install each and every component individually: pig, hive, scoop, flume, Uzi, zookeeper. Okay. On top of that, you need to maintain it for any failure. Also, there is one advantage of Hadoop that I missed, which is Hadoop is an open source. So when I say it's an open source, what does it mean? I mean, it's free to use. It's completely free to use, whether it is being used by any company or by an individual. It's free to use. So if it's free, then who is responsible for maintaining this entire ecosystem? And every year we are getting new versions, right? And there is a new boom to market, which is Spark, Scala, right? It's a new boom to the market, and it's like in every couple of months we are getting a new version. So who are actually paying to them and how they are actually earning money from them? So I'll say Apache Foundation is responsible for its development and maintenance. Okay, something like that, which is completely free of cost. So how Apache is earning money from that? So actually Apache are getting lot of funds from companies, from different companies. Okay, so if you want to install a Hadoop system in your single node, basically we install, why? Because 4 node, 5 node, from where you will bring system or device in partition. So for learning purpose, we should always focus on single node. So for single node system, we need to install each and every, first you need to have a VM player, then 8 GB RAM is fine, then 50 GB of space is also good enough, and the ecosystem you have to install as per your requirements. For learning, you can install the ecosystem separately. Now, there is another way to use the Hadoop, which is like you can use VM images like Cloudera, Big Insight, which is developed by IBM. Cloudera is an open source, but again I can say it's limited. I mean, for learning purpose, yeah, it's fine. But for if you want to go more advanced, you need to pay for that. Big Insight, then Hortonworks. So these are the VM images that we have available in our market to use. So when I say VM image, it's a ready-made image that is having all sorts of component pre-installed. Okay, so you no need of doing any extra effort, putting extra effort on any work. You just need to work on it. Also, it provides an UI interface to deal with the nodes, to deal with the different services. Different services mean the ecosystem. Different services, nodes. Okay, so it is getting used in real time. Real time means all the big companies or small companies also, they preferably use Cloudera, because for any failure or anything, they actually get support from if they are using these products also. So, but RAM, you should have at least 16 GB. I am saying at least, means more than that is required. Hard disk space, you can give 50 GB, that is fine at least. But RAM, high quality RAM is required, and even 16 GB is also not much sufficient. But when it comes for learning and to understanding in the real time perspective also, this is fine. Installing Apache Hadoop, and in my classes I'll go through both. You will never find a difference like, okay, I'm not learning, I'm not going through Cloudera. I'll go through all the things like through Big Insight also, and the single node system as well. So that won't be a big deal. So prerequisite for Hadoop, I can say, for learning Hadoop is core Java, which is not completely, but yeah, serialization, collection, not collection, I can say generics, then comparable comparator. These topics are very important. Then little bit Linux knowledge is required, but what I am saying, like, don't bother about that. Okay, I don't know this, I know. I will be taking care of entire thing if you are not very much comfortable with the serialization or generics or comparable or comparator. And Linux knowledge also, I'll discuss wherever it is required, whatever is required. Okay, so also I'll help in the installation as well. And yeah, that's fine. That is sufficient to learn and understand the big data. So this is all about today's classes. We'll discuss about more introductory thing of Hadoop in the next section. Okay.